0.5 font. I'm going to get me some binoculars or something. Our objective for today, I can solve and graph compound one variable inequality. Let's read together. 1, 2, 3. One more time. 1, 2, 3. So today we're continuing with the lesson that we started yesterday in regards to compound inequalities. Now, just to recap in what we saw yesterday, we saw that, well, we know what one variable inequalities are. We know the steps that we're using, right? Simplify, isolate, plot, and check. Yes? And then I illustrated and reviewed what we've been doing with inequalities, how to solve them using inverse operations. We solved, we graphed. This one was one of them. I give you another. We solved, we graphed. There it was. And then we talked about that the word compound means to combine. Is that correct? And I gave you these two, and I said, I'm going to combine this one. And I used some animation, and I combined it with this one. And as soon as we combined that, it became a compound inequality. So I brought this one down, and we understand that this is what we started looking at. Is that correct? Yeah. From there, I said copy example 1A. You did that yesterday. Is that correct? Then we went to this one. Is that correct? Yes? All right. So did we get to this one? No. Copy that one, please. Example 1C. And let's see how you do. Copy that one. Go. Let me show you the process. Here we go. Here goes the process for number 1C. Look up to the screen, please. Writing utensils down. Here it goes. Line down the inequality symbols. To isolate the variable, we need to add 10 to all sides. Is that correct? And then we're left with 1 less than x less than 5. Okay. From there, I said, let's graph it. Okay. Number line. And we got, here it is. Then we got 0. I'm going to start with the dividing points right here. So I'm going to start with the first part of the graph, which is open point. And it says 1 is less than what numbers? 1 is less than all these numbers to the right. Is that correct?
Yes, yes, yes.
Then I'm going to do the second part in blue. Dividing point is 5. It does not include the point. There it is. X is less than what? I'm sorry. What numbers are less than 5? Everything to the left. And if we can see, this is an and inequality. And then because the solution is this and that. So here we go. So how do we write the solution set? Here we go. Solution set for all x's such that for these with and, we write the dividing points 1 and 5. And we know that the solution is in between here, right? And what variable represents it? X. Is this an open point? Yes. Is this an open point? Yes, and that's how we write your solution set. Yeah. Hands if you got that by yourself. Okay, good. All right. Let me send you another one on your screen. I want you to do this one on your screen. If you still feel that you can't really do a lot of work on the screen, then do it on paper and try and get that to me as soon as you finish. Here goes the next one. Example 1D. Says solve, graph the solutions. -4 less than or equal to 3n plus 5 less than 11. Copy that and solve, graph, and write your solution set. Go. So let's go on to the next one. Example 2A. Don't copy this one. Look up to the screen. Write your utensils down. Now, notice this one is a little bit funky, right? It looks a little bit different, but look how we solve these. Look up, please. Write your utensils down. It says solve and graph the solution. So now I have two inequalities, but it has an or in between. So let me solve this. If I was to solve this, I would need to write my line down the inequality sign, subtract 8 to each side, and this becomes t is greater than or equal to -1. Or this one, -8 minus 8, t is less than -6. Yes, any questions? You can, or just wait until I forward. Okay, is everybody there?
Yes, sir.
So watch. So now we have this situation. But, well, let me graph this. There it goes. Focus, please. Stop looking at your iPad. Look up to the screen. We got 0. We got -1. And we got -6 as my dividing point. So I'm going to start with this one in red. This one says, what numbers are greater than or equal to -1? Does it include -1? Yes. What numbers are greater than -1? Everything to the right. Okay. I'm going to go with blue for this one. Does it include the dividing point? No, it's an open point. And this says, what numbers are less than -6? What numbers are those? Everything to the left. What do you guys notice now on these? They do not what? Intersect. Is that correct? That's why these are known as OR inequalities, because the solutions are this or that. Does that make sense? Now you're saying, Mr. Q, but how do we write the solution set for this one? This one's a lot easier than the previous one. Watch. Solution set of all t's, pay attention please, and I write the first inequality, t is greater than or equal to -1, or, what is the second one? T less than -6. That's it.
That's really long.
Hands, and show me how you feel with these, 1 being the lowest, 5 being the highest for the ORs. Okay, we got some 3s, 4s, 3, 4s, 5s, 1, 2, 3, 4s, 5s, okay? We need some practice, right? Here goes another one. Do this next one by yourself. See how you do with this one. Example 2B. Copy that on paper. Do that on paper. It says, solve and graph the solutions 4x less than or equal to 20 or 3x greater than 21. Copy that and go. All right, check with the neighbor, see what they got really quick. And I'll go over this process just to make sure we got it. All right.
I got eggs, but that egg is less.
Here goes the process. Line down the inequality symbol, divide by 4, divide by 4. We got x is less than or equal to 5. Or, line down the inequality symbol, divide by 3, divide by 3. X is greater than 7. Hands up, you got it to right there. Okay, good. Then we got our number line. It's crooked? Okay, hold on. Let me fix that. Let me fix that. There you go. All right, so we got 0, 5, 7. So I'm going to grab this one first. Does it include the dividing point? Yes, solid point. And it says, what numbers are less than 5? Anything to the left. All right, and then from there I'm going to graph this one in blue. Does it include the dividing point? No. What numbers are greater than 7? Everything to the right. And this is a what? OR. So my solution set for all x's such that x less than or equal to 5 or x greater than 7.
So easy.
Hands if you got that. Okay, the last thing that I wanted to cover with these is that instead of using the word OR, you can use also a symbol that is used in mathematical terminology, which is the letter V. The letter V stands for what word? OR. So if you, so here it goes. In the solution set, you can either use the word OR the letter V for OR. Because I said so. No, just kidding. Just so you can replace the word instead of writing less words, okay? Hold on, before you log out, give me a second. I'm going to send you a quick poll to see how you're doing with these. You don't need paper. There it is. As soon as you answer that, home play is a play sheet. Just come pick that up. Good one. See you guys tomorrow. Bye.